Hi everyone. So today I come to section 9.1, system of linear equation in three variable. So in this session we're going to discuss how to solve a system of three linear equation in three variable. Um, and a system of linear equation can have three cases. Um, so one is no solution. Another case, one solutions, and the last case could be infinite solution, right? So let me have for each case here. All right. So um, for the system linear equation of three variables in the form as say ax plus by plus z have a c z equal to d, showing that, and say a1 b1 c1 d1. I have a2x plus b2y plus c2z equal to d2, and then a3x plus b3y plus c3z equal to d3. And remember that you should have a1, a2, a3, b1, b2, b3, and c1, c2, and c3 um, are constants and not equal to 0. It could be 0 actually. Yeah. Okay, a constant. So let's talking about checking for solution to a system of three equation. And I have an example. Number one, say determine whether 4 to -1 or -1, 0, 3 is a solution to the system. So system in here is 2x minus 3y plus z equal to 1. X minus 2y plus 2z equal to 5. And then 2y plus z equal to 3. Okay, so firstly, let's check the first part in here, 4 to -1. I'm going to say that is x1, is y1, and is z1. Okay, in order to check this, I need to substitute x equal to 4, y equal to 2, and z equal to -1 into the system. And I have 2 times with x is now equal to 4, right? Minus 3 times with y now equal to 2. And then plus z is equal to -1 equal to 1. Is that true? I will check it later. Second one, I have 4 and then minus with 2 times with y in here is 2, and then plus with 2 times with z, z is -1, and then this equal to 5. And the last equation is 2 times y is 2 in this case, and plus z is -1. So it's -1 here, and that's equal to 3. Okay, let me simplify for each equation. The first equation give me 8 minus 6 minus 1 equal to 1. Is that true? So yes. All right. And the next one give me 4 minus 4 plus minus 2. So okay, 4 minus 4, 4 minus 4 minus 2 equal to 5. No, it is not true, right? And then the last one give me 4 minus 1 equal to sorry, let me write right one. 4 minus 1 equal to 3. Is this even this is true answer, but because there is one equation that not satisfied, so I'm gonna say 4 2 -1 is not a solution. Okay, since only one equation not satisfied, then this is not a solution. Okay, now let's check another one. So check I will check -1 0 and 3, right? So substitute x equal to -1, y equal to 0, z equal to 3. So I put x2, y2, and z2 here. So people can remember it. So I have, let me put it here so we have more space. Have 2 times with x now is -1, minus 3 times with y in here is 2, and then plus with 3 here, z, because z is equal to 3, and then I go to the next one is x equal to 4, and then I minus with 2 times y, right? 2 times y, so 2, and then plus with 2 times z, which is 3. Okay, so I forgot to put equal to 1 equal to 5, and the last equation is 2 times with y plus z, which is 3. Okay, equal to 3. Okay, so now I gotta substitute. I'm gonna simplify for each equation. I have 2 -2 minus 3 times 2 is 6. So minus 6 plus 3 is equal to 1. So I have oh, this is 0. Why I put 2 here? That's what's wrong. 0. This is -1. Yep. Okay. So so that should be -0 plus 3. That should be okay for the first equation. And I have the second one give me -1 minus 0 plus 6 equal to 5. This is show statement. Choose each question. and then have 0 plus 3 equals to 3 is also true. So so I'm gonna say -1, 0, and 3 is a solution. Okay, so since it satisfies all the equation, then this should be a solution. Okay, so let me move to the next page. What happened? Okay. Okay, now. Okay, so now let's talk about setting up a system of equation. Okay, so example 2. Okay, so I have just copy down a example. Okay, so I have the measure of largest angle in a triangle is 40 degrees greater than the sum of two smaller angles and 90 degree more than the smallest angle. Okay. We're going to set up the system of three linear equation in three variables whose solution gives the measure of each angle. So what I should do for this case is I'm going to let the solution here. I'm going to let x, y, x, comma, y, and z be the measure of the three angles from largest to smallest. Okay, so so we have sum of three angles in a triangle is what? 180 degree, right? This degree, 180 degree. So what happened is okay. Degree. Okay, so I have x plus y plus z will be equal to 180, right? That's gonna be the first equation. What else? What else? So we have measures. Measure of. I'm gonna just copy down. The measure of the largest angle in the triangles is 40 degrees greater than the sum of two smaller angles. So I'm gonna put that here. So I have x x what happened? X one copy down. Okay. x minus for the sum of the other two angle, right? Gonna be equal to 40 degree. 40. So if I simplify this, I'm gonna have x minus y and minus z will be 40. And this should be the second equation. Okay. What else do I have? I have the measure of the largest angle is so the measure of the largest angles is 90 degree more than the smallest angles. So I have x minus z, because z is the smallest one, right? Will be equal to 90. Okay, so, and this I call the third equation. And then I'm gonna combine three equations above to get the system. To get a system of equation. Okay, so we have, let me write out, x minus y, x plus y plus z equal to 180, and then x minus y minus z equal to 90. So no, 40. And then last one going to be x minus z equal to 90. That should be the answer of this problem. All right. Let me circle this one. Okay. So now I'm going to talk about solving linear system with substitution and elimination. So remember that we have two methods to solve linear system. The first one is substitution. The second one is elimination. Okay. So let's start with substitution first. So let's start with substitution. Okay. So I'm going to have substitution. Let's do an example. So I have example number 3 here, right? Yep. Okay. Use substitution to solve a linear system. I have 2x minus y plus z equal to 7. I have 3y minus z equal to 1. And the last one is z equal to 2. So in here, note that the third equation, z equal to 2, has been isolated variable z already. Okay. So what I should do is I will substitute z equal to 2 into the second equation. Let me put, here's 1, here's 2, and here's 3. Into equation number 2 to get 3y minus z equal to 1. Now z changed to be number 2. So you what you do is gonna add 2 both hand side, and you get 3y equal to 3. And you're gonna divide by 3 both hand side, and you will get y equal to 1. Okay, so now you have y already, you have z already, right? So you will use y equal to 1, z equal to 2, and substitute into equation number 1. And you will have, move down, 2 times x. I haven't yet, right? Minus y. Okay, so y now is number 1. And then plus with z, which is number 2, will be equal to 7. And simplify the left hand side, you will have 2x plus 1 equal to 7. And then what you do, you're going to subtract both ends side by 1. You're going to have 2x equal to 6. And then it divided by 2 both hands side. And you will get x equal to 3 as the last variable. So remember that the solution has to be in the form as x, y, and z, right? It should be solution has to be something in the form as x, y, and z, okay? With equal to, so x was 3, y is 1, and z equal to 2. Okay, that's the answer. Okay, so let me make a summary for this. Okay, so we have, oops. Oh. Okay, to solving a linear system in 3 variable, step number 1, you need to eliminate one variable such as x from 2 of the equation. And then step number 2, you're going to use the 2 resulting equation in 2 variables to eliminate one of the variable such as y, and then solve for the remaining variables, which is z. And So then you after that you're gonna substitute z in one of the two equation from step 2, and then solve for the unknown variable y, and lastly you substitute y and z into one of the given equation and find x. So the solution should be in the form as x, y, and z over here. Right? See that? Okay. So let's do an example and see how can I apply this. So example number what's that number? 4. Is that 4? Yeah. Okay. So I want to solve the system below. X minus y plus 2z equals to 6, and then 2x plus y minus minus 2z equal to -3, and negative x plus 2y, sorry, not plus, minus, and then plus 3z equal to 7. Okay, so solution. So what is step number 1? Let's use step number 1 first. Let's see. Let's see. Step number 1. Step number 1. I want to eliminate. Actually, you know what? I'm gonna copy all this and then put that here. So I don't forget. Okay. Let's start with step number 1. I want to eliminate one variable in here, such as x from 2 of the equation. I'm gonna do use first one and the second one. That two, here's 1, 2, and 3, right? If you use you know what, the easier, I would like to use the second and the third one from the, so I'm gonna eliminate variable x from 2 from the equation 2 and 3. Okay. So what I do was 2x plus y minus 2z that for the second equation, but I need to use the first equation, so I'm gonna write x minus y plus 2z equals 6. This is the first equation, and the second one is 2x plus y minus 2z equals to -3. All right. So what I do is I'm gonna multiply both sides of the first equation here with -2, because later on I'm gonna, from this -2, I will have cancel this x when I adding these two, right? -2. Okay. All right. Like this. So I have -2x plus 2y minus 4z equal to -12. That's from the first equation. Okay. And then we're gonna separate this. The second one I put down 2x plus y minus 2z equal to -3. Okay. Now I'm gonna adding to this equation. Okay, so adding to this equation to get the first one, first term gone because -2x plus 2x is gone. And 2y plus y gonna be 3y minus 4z plus with a -2z gonna be -6z equal to -15. Okay. So now you have a new equation with new second equation with no x, no variable x. Adding to get new equation 2. Okay. Adding to get new equation number 2. All right. So let's move to the third one. The third one was -x minus 2y plus 3z equal to 7, right? And I'm still using the first equation, x minus y plus 2z equals 6, to eliminate variable x from equation number 3. So in this case, I don't even have to multiply with anything. I'm just gonna adding them. So remember that is the first one. Here's 3, 1, right? So I have adding. I'm gonna have, so x minus x 0, and then -y minus 2y gonna be -3y, and then plus 5z equal to 6 plus 7 gonna be 13. So this gonna be new equation 3. Okay, new equation 3. All right, so I'm done with eliminate one variable x from equation 2 and equation 3, and I have new equivalent system. New system. Just a new system. Yes. X minus y plus 2z equal to 6. And the new number 2 equation is 3y minus 6z equal to -15. And the new third equation will be 3y plus 5z equal to 13. Okay. So I'm gonna still put that 1, 2, maybe put 2 prime here and 3 prime here, right? Okay. And then step number 2 is I'm going to use 2 resulting equation in 2 variable to eliminate 1 variable, or I'm going to eliminate variable y, and then solve for the remaining variable, and then solve for z. Okay, so let's use 2 result equation, which is 2 and 3, right? I have 3y minus 6z equal to negative 15, and I have negative 3y plus 5z equal to 13. And I don't have to multiply with anything to eliminate y in here, because they have 3y and negative 3y. So that's just gonna adding and make it become 0y. And I have negative 6z plus 5z gonna be negative z equal to what? Equal to negative 2. So you will actually have z equal to 2. Okay, you actually can have z equal to 2 at the maybe at the solution for z. So from here, I'm done with step number 2. I'm gonna go to step number 3. I say substitute z equal to 2 in one of the 2 equation from step 2, and then solve for y. Okay, so what does that mean? I can either substitute this z equal to 2 into 2 prime or 3 prime over here. Doesn't matter. So let me choose 2 prime, and I have like 3y minus 6 times z. Z equal to 2 in this case, equal to negative 15. So then I have 3y minus 12 equal to negative 15. I'm going to add 12 both hand side to get 3y equal to negative 3. And then I divide by 3 both hand side to get y. Let me move down one more. So then I'm going to get y equal to negative 1. And finally, I'm going to substitute y equal to negative 1 and z equal to what? 2 in one of the given equation to find x. So you know what? Either 1 or 2 or 3, but I'm gonna use just in equation say 1 to find x. Okay, and the solution is x by z. So let's use. So we have the first equation was x minus y. So y in here is negative 1, right? And plus with 2 times z. What is z in here? You know, z equal to 2, right? And then equal to 6. So combine and simplify. I have x plus 1 plus 4 equal to 6. And you can minus 1 and minus 4 both inside. And lastly, you will get x equal to 1 as the answer. Okay, so solution has to be in the form as x y z, right? 1 is x, y is -1, and z equal to 2 as the answer. Okay. So, yeah. Okay. So let's have another example. I believe that you need it. So I have another example over here. Example, what's example we're having now? 5, right? 4. Okay, so now it's 5. Example 5. Okay, so we have, we want to solve x plus y plus z equal to 1000 and 3x plus 4y plus 5z equal to 3800. And the last one is y minus z equal to -100. So in here, you can see that, so here's 1, 2, and 3. Note that equation 3 has eliminate eliminate XR, right? So so what I should do in this case is I just gonna try to eliminate maybe equation number 2 over here by using the first one, right? From in step 1, I'm just gonna try to eliminate variable x in equation number 2 by using equation 1. Okay. So I have equation 1 was x plus y plus z equal to 1000. And 2 was 3x plus 4y plus 5z equal to 3800. So what I need is I need to have a -3 over here, right? Since I need to have -3, I need to multiply by -3 for both inside of the first equation to get that's -3. So I have what? -3x minus 3y minus 3z equal to what? -3000. And the bottom gonna be stay as 3x plus 4y plus 5z equal to 3800. That is the second equation. Now I just adding both of them, right? Adding both of this equation. I have new equation that doesn't have variable x at all. So we have negative 3y plus 4y gonna be y, and then plus with 2z equal to a n dash. So then, yep. So this is gonna give me a new equation number 2. Or you can say equation number 4. That's fine. So maybe in this case, I'm gonna say equation number 4 instead of say 2 prime. Okay, so now you have now you're gonna have new system as and the first one is x plus y plus z equal to 1000. Second one is y plus 2z equal to a n dash. And the last one is y minus z equal to minus 100. So I know this is 1, I know this is number 4, and I know this is 3. Okay. And what I do is I need to eliminate, I need to move to the step 2. I need to eliminate variable y in equation number 3. Eliminate y in 3. Okay, so what I do is I'm going to use equation 4 and equation 3 to do that. So y plus 2z equal to a n dash, and then y minus z equal to negative 100 dash. Okay, so I need to multiply by negative 1 for both inside of the equation number 4, right? So I will get negative y minus 2z minus 800 and y minus z equal to negative 100. Okay. Now adding, I have 0y negative 3z equal to negative 900. And then I just divide by negative 3 both hand side. And I will get z equal to 300. Okay. For from here, I'm gonna substitute. So step 3. Right? I'm gonna substitute z equal to 300 into either 3 or 4. Doesn't matter. Okay. So I will say I'm going to use into 3 in this case. Okay, either 3 or 4. Into 3, I have y minus z is 300 will be equal to negative 100. And then I have y and a plus 300 both hand side. I have y equal to 200. So then you're gonna move to step number 4, which is final step, right? That you're gonna substitute y equal to 200 and z equal to 300 into equation 1. Okay, equation number 1 into equation 1. Okay, so you want to have x plus y plus z, right? X plus y now, y now is 200, and plus z now it is 300, equal to 1000. And then you're gonna substitute, subtract 200 both 300 both sides, and you will get x equal to 500. So from here you can say solution is 500, comma, what's the y? 200, and z is 300. Okay, so all right. Remember that I have mentioned that for linear system is could have it could have the case that have no solution. Linear system, let's say no solution. Linear system, right? I did mention that it's also it could have the case that we have no solution in this system. So when it's happened, let's take a look at example number 6 here. So, 6, sure, 6, yes. So I have x plus y plus z equal to 4, and then another one is negative x plus y plus z equal to 2, and I have y plus z equal to 1. Okay, so I want to solve this system. So I'm going to use in here. You should note that the third equation that has eliminated the x variable already, so we're just gonna eliminate the second one only, right? So so now let me go to step 1, which is eliminate x in equation 2. So you have x plus y plus z equal to 4, and second one is negative x plus y plus z equal to 2. You're adding them, you're gonna get what? You're gonna get 2y plus 2z equal to 6. Okay. So this is the equation number 4. So you move to step. Oh, what happened? You move to step number 3. We're gonna eliminate. Try to eliminate y in 3 and 4. No, actually, in 4, in 3. Okay, in 3. How can I do that? I'm gonna use equation number 3 and equation number 4. So I have 2y plus 2z equal to 6, and equation number 3 is y plus z equal to 1. So I need to maybe let me see. How about this? Instead of eliminate y in equation number 3, I eliminate in equation number 4. It doesn't matter, but yeah, okay. Let's do 3. I will just multiply both sides of the 4 with negative 1/2. right? Because I need to make the 2y become negative y. So this give me negative y minus z equal to negative 3. Okay. And then I have y plus z equal to 1. So then when you're adding them, you will get no z, no y, and no z equal to negative 3 plus 1, which is negative 2, which is not true, never true, right? It means what? 0 equal to negative 2. That's not never true statement. Not true. So since it's not true statement, you're gonna just stop here and say no solution for this system. Okay. Also, I have mentioned that it could be infinite or infinity, infinite infinitely many solution. Could be some linear system. And how we can recognize it. So let me have an example for you to see. Okay. All right. So let's have x plus y plus z equal to 2, x minus y plus z equal to 4, and 3x minus y plus 3z equal to 10. Okay, so I must start with step 1 is eliminate x in equation 2 and 3. There's 1, there's 2, and there's 3, right? So how can I do that? I start with the equation number 1, x plus y plus z equal to 2, and here's I have x minus y plus z equal to 4. So I need to have minus x in here. I need to multiply by negative 1 to the left and right of the first equation, and then I get negative x minus y minus z equal to negative 2, and then x minus y plus z equal to 4. So I will just cancel out this stuff and get negative 2y equal to 2. So right away, I can have y, I divide by negative 2 both sides. And have y equals to negative 1. Okay. So, okay, that is for y. I also want to use, I'm also going to eliminate x in the equation number 3. So I use x plus y plus z equal to 2 and 3x, right? 3x plus or minus y plus 3z equal to 10. Okay. So I had to have -3 both hand sign for the top in order to eliminate x. Then I have -3x minus 3y minus 3z equal to -6. And that's the third equation gonna stay equal to 10. So what you have from here is you also gonna cancel out x and z and get only y and -4y equal to 4. Let me see, -4y equal to +4. And then you divide by -4 both hand side, and you get y equal to -1. So from here, you don't have two new equation, but you have only y equal to -1. So what you do is you substitute back into the system. New system gonna be x minus 1, actually x plus y, but y now is -1, right? And then plus z equal to 2. And you also have x minus y, now we can make it 1, plus z equal to 4. And the last one is 3x minus -1 and plus 3z equal to 10. So if we try to simplify and you adding both hand sign of each equation with 1, you will get x plus z equal to 3. For the second equation, you need to subtract both hand side by 1 because this is x plus 1, right? So I have x plus z also equal to 3. And the last one give you 3x. You subtract 3, sorry, subtract 1 both hand side, you get 3z equal to 9. So you can see that all of this, so note that I have say here 1 prime, 2 prime, and 3 prime. Note that 1 prime and 2 prime, 1 prime equal to 2 prime and equal and equal to 1/3 of the third prime. So you can see that, and seeing that happen, right? Seeing that happen, you will never had a specific x and z. But it actually can tell you that there's only one equation, only one equation from these three equations as x plus z equals to 3. Because if you multiply by 3 for both sides this guy, you're going to get the 3x plus 3z equals to 9. So you just keep it as x plus z equals to 3. And then you solve for x. In terms of z, you get x equal to 3 minus z. So if you want to say the solution, you're going to have all solution have the form. So x now become 3 minus z, okay? And y now, what is that equal to? Y equal to -1. And z is just z. You don't know z. Z is a variable, okay? So z can be anything. Okay. So so that should be the answer this problem. Okay. So in this case, you have like many solutions, infinitely many solutions for this problem. Okay. So I could like to stop this 9.1 here, and let's see you in the next session. Bye.